All right, let's get started here with the introductions. I'm very happy to welcome back Laura Frank. She on this track, which is using Docker for developers. This is Laura's second presentation on this track. We're going to be talking about development environments and using containers for those. So it's going to be an interesting session for all of you hands-on developers here. Imagine a situation where a new developer comes on board and needs to get set up with development tools, and it's all there, ready to go. And that's what the talk's about. Laura is a Docker captain, Captain Plus Plus. She's been using Docker for many, many years now, since 2013, I think. Laura lives in Austria, in Vienna, and speaks German fluently, but will do the presentation in English.
I could do it also in German, but I don't think I could. All right, welcome everyone. Hope you're having a good DockerCon so far. Today we're going to talk about using Docker for development. So this is all about being productive, being efficient as a developer at your local workstation. As I was already introduced, my name is Laura Frank Taco. I'm working at CloudBees as the Director of Engineering. I was formerly with CodeShip, and we got acquired by CloudBees earlier this year. I'm also responsible for the Jenkins X engineering team as well. Spend a lot of time in the CI/CD space, so if you have any questions about pipelines or CI/CD, feel free to ask me after this talk as well. You can follow me on Twitter. If you have questions, I'm usually pretty responsive on there as well. Cool, so to start, I want to present you with this trail map, which I think many of you have seen. I had some interesting conversations yesterday at the women's networking event about whether this is a great thing to present or not, because it presents this very straightforward version of reality, or a straightforward version of like how you get to cloud-native applications, and in reality, this isn't really true. But the important part of this trail map, and I think one thing that we can take out of it, is that containerization is step one. So without your application running inside of a container, all of that other stuff, orchestration, monitoring, it doesn't really make sense, and you're not going to be able to use it. Containerization and your container images are the most important part of your cloud-native application, which is why I'm going to focus a lot on them today during this talk. So I'll split this talk into three parts. First, we're going to start with Docker Compose basics. Docker Compose is a really popular tool for using Docker for development, so we'll dig into some of the best practices for using Docker Compose. We'll then talk about how to optimize your images, how to write Docker files elegantly and efficiently. And then finally, we'll get into some more live demo using VS Code and being able to debug your local dev environment using VS Code while you're running your application in containers. So let's start with Docker Compose basics. For this talk, and even day-to-day when I'm writing code, I use a pretty small set of developer tools, oddly enough. So I'm using Docker Compose, which comes with my Docker Desktop installation. And this morning we heard about Docker Desktop for Enterprise, so if you haven't been able to use Docker Desktop before because of the way that it was distributed, your problems are solved now. Docker Desktop is by far the easiest way to get started with Docker, Docker Compose, Kubernetes, Swarm on your local machine. Everything ships, you know exactly what you're getting, and it makes it just really easy for you to get productive really quickly. You can check it out on the Docker website if you haven't downloaded it already. If you're brand new to Docker, I would recommend starting here. And for this talk, I want to use a sample application, which you may have seen at DockerCon's past, or even in other talks here at DockerCon, which is the cats versus dogs voting application. So this application is actually kind of funnily over-architected, and the point is that we have lots of microservices, and these microservices are making our sample application possible. We can vote for cats or dogs, and then we see on the right-hand side this nice little voting pane, or the result pane that shows us who's voting for what. You can grab this code on GitHub. I have a fork of it where I've sort of adapted it a little bit for this demonstration, but the Docker samples GitHub organization also has this code. It's pretty much more or less the same, so if you want to have a simple application that's easy to get it started with, I would recommend starting with this one. So this application, as I mentioned before, it's a little bit over-architected. So you as a user put your vote in, and the voting application is a Python app, which then sends your vote to Redis, which then gets picked up by a worker that's written in .NET, which then gets to a database, which is Postgres, and then there's a Node.js result application that's reading the results of the voting and putting it into that nice voting pane. This is actually a pretty cool application because it shows us different kinds of applications or different kinds of services that you'll use when you're developing applications locally, and gives us some good examples of what kinds of services we run in which way, getting images from which place. So these services on the very top, the vote, worker, and result, those are services that we have to write code for. We're going to build that code into images. The dependencies on the bottom, Redis and DB, we don't actually have to write any code for that. Those are going to be images that we simply just take down from the Docker Hub and run them in our local development environment. So this will present some challenges because we have to figure out a way to get our application to talk to that database in a container or Redis in a container. But thankfully for us, we have Docker Compose, which makes things pretty easy. And to show how easy it is, I will launch into my first live demo after not eating any grapes, so hopefully everything's fine. So I just catted out the Docker Compose YAML file. If you go to the example voting app or any other app that's using Docker Compose, you'll find this file. And it's basically a way to describe the environment or the application. Everything you need to be running is inside of this Docker Compose file. So we have all of our services here. There's some extra information like port bindings, et cetera. And then I'm going to simply say Docker Compose up. I'll pass in a flag to keep my terminal nice and tidy. And then I can go over and just verify that my application is up and running, which it is. So I can see my cats and dogs is up and running. I don't know anything about .NET. I am not a database administrator either. I'm working on a Mac. I just issued one simple command, and I have my entire development environment up and running, which maybe seems like, yeah, this is a demo, so of course it was really easy. But actually, as a developer, and if you're trying to share information across teams, Docker Compose becomes a very powerful tool for you to share your applications, not just with your teams, but also with QA and anyone else who might be a stakeholder. All right, so we're up and running with Docker Compose. Let's see. What actually happened, though, when I said Docker Compose up? Because it seems like there's a lot of magic going on, like it couldn't really be that easy, right? So Docker Compose is basically one layer of abstraction on top of just Docker. So you're no longer running just a container, you're running an entire application. And that's sort of the level of abstraction that you're working with when you're working with Docker Compose. So you're no longer just interacting with containers individually, you're interacting with an application as a whole. And that can be a little bit tricky if you're new to Docker or new to developing with Docker, kind of a tricky abstraction to wrap your head around. So if we look at the very top, when we run a Docker Compose PS to see what Docker Compose is running, we'll see a match up. Everything that was in my Docker Compose file is in that output. I have the database, result, vote, worker, et cetera. But Docker Compose is a separate tool from Docker. So where are these containers coming from? Docker Compose is sort of acting on your behalf to start up the containers that you've asked it to. So if you issue a Docker PS to look at what Docker is running, you can see, like the magic is sort of exposed to you, that it's really just using Docker under the covers, but you're no longer responsible for running 5 separate Docker run commands to get your application started. You only have to run the Docker Compose up command. Everything matches up. It's sort of everything is exposed to you. But Docker Compose does wrap it in some nice UI and UX. Cool. For example, we can see the Postgres database. It's identical. It's just that you're interacting with it sort of on a different level. So that's great to get your application up and running. But what happens when you need to actually start editing the source code? So we have over here, you'll have some kind of text editor, whether it's Vim or VS Code or whatever you're using. You want to use your text editor to edit that source code. But that source code is in a container, and like somehow it needs to get to the browser. We need to do a little bit of connecting the dots, and we want to see those browser changes immediately. We want to do this without having to restart containers or having to issue more commands on Docker Compose. And the way that we can do that is basically putting your local code and mounting it inside of the container. And if you're using Docker Compose for development, this is probably the very first pattern that you're going to come across, is this idea of mounting a volume, or pushing your local code into the container via a volume. This is because during your experience with Docker, this will also come up many times, there's a difference between things you declare at runtime and things you declare at build time. So if I'm building an image and put some files in it, I can overwrite any of those files at runtime, and runtime will always overwrite the build time, which is why I'm able to put my local code via the volume mount and overwrite anything that I might have put into the container image before. Then I can edit my code locally and have the changes reflected up into the container and then eventually into my web browser. I can also view the changes in my web browser because I'm publishing a port to make sure that my local browser on localhost is able to access inside of the container. So I'm pointing to just localhost 5001, which is then pointing to my container where I have the service running on port 80. This is all a little bit hard to visualize just in your head, so it's a little bit better for a live demo. So you'll notice maybe I have this like cats and dogs, but the colors don't match what I have in my presentation, which is fine. I'm going to run this really simple script to change the colors. Notice I'm running this just in my terminal. This is my local code, but I'm running my application inside of Docker containers. So I want to change the color to purple. And then I can see when I refresh, and actually this is probably better over here, that I didn't have to do anything with Docker. I was able to edit my local code just via Vim or whatever and see those changes propagated all the way up to the browser and get that immediate feedback without having to rebuild an image or do anything else with Docker Compose because I'm using that volume mount. Cool. So now we have everything the right color, which is very good. What about dependencies? So we talked about two dependencies for this application. One is Redis, and one is Postgres. And it can be a bit of a stumbling area to figure out how to get your, for example, my worker to be able to connect to Redis, because they're both running in containers isolated from one another. Docker Compose makes this really easy for you. So any service name, for example, Redis, is available as a host name in your Docker Compose environment. That means that inside of my application, I can reference that Redis service not by IP or need to worry about figuring out where exactly the container is running, but instead I can just reference it by that service name called Redis, and it will connect. So I have Redis over here in my Docker Compose YAML file, and then when I have to set up the connection to Redis in my Python file, I can simply say host equals Redis and pass in the host name of the service. The same goes for any service that you're running with Docker Compose. This is especially handy for services like Redis or Postgres. You don't have to worry about, oh, where do I find the IP? How can I know where this is running? Just use the host name. It's a lot easier. I should say the caveat that running databases in containers is probably one of the hardest problem spaces of developing with Docker. So persistent data in containers can sometimes not be the best of friends. If you're just getting started or you're just starting to containerize your development environment, don't start with a database. Save that until last. And in fact, you might not even have to put your database in a container at all if you're not quite ready for it. So if you're using RDS, for example, you can set your containerized application up and have it just point to RDS. You don't have to run your database in a container. It is a very challenging problem space. If you look at the source code for this application, you'll notice that we are running our database in a container. This is not a production-ready application, like no customer's paying me to run the cats versus dogs voting app, unfortunately. You'll notice, though, if you look through this Docker Compose file, there's a new concept introduced called data volumes. And a data volume basically lets the data persist outside of the life cycle of the container. So containers are ephemeral, they're fast to boot, you can kind of spin them up and throw them away. And what happens, though, is that all the data also gets thrown away when you throw them away like that. If you have a data volume, that data gets stored in the volume. That volume persists outside of that ephemeral life cycle. So in this example, we have our DB data volume, and we can see that it is also varlib Postgres data. So anything that gets written to my Postgres database is also going to be in that volume. If I take down my Postgres database, the container, that data volume still hangs around. That means I can mount that data volume into a new container and kind of restore the state of my old database. This is a trick that's really helpful for development because it's kind of annoying to have to go through and seed your database and get it set up. I wouldn't recommend necessarily this lightweight of a workflow for production. I do know some people that do it. But data volumes will help you kind of understand how to manage persistent data outside of the lifecycle of your container. Great. Those are just some fundamentals for using Docker Compose and getting started. The next big topic I want to talk about is optimizing the images that you're building with your application code package inside of it. We saw containerization was that very first step on the cloud native trail map. And that's because your Docker files and your container images really are the heart and the most important thing of your application. Every other thing, Docker stack deployments using Swarm, using Kubernetes, rely on the fact that you're using containers already and you have images. So if you don't set up a good foundation in these Docker files, it can sort of lead to a lot of problems later on. If you are brand new to Docker and you haven't even written your first Docker file, a quick intro or a quick description is that a Docker file is simply a list of instructions with everything necessary to get your application up and running. We will start with a from image. One way to make your applications and your images a little bit smaller is to really pay attention to what is going on in this from image. A lot of them are sort of like kitchen sink images, and those are great to get started with. If you are using one of these kitchen sink images, so for example, just the regular Node 10.9, not with the Alpine, that would be sort of a kitchen sink image. What they're trying to do is put in everything to make sure that for 99% of people, that image is going to have the right packages and dependencies to run your applications, like everything but the kitchen sink. But that is big. So oftentimes, these official images distributed on the Docker Hub have some tag called Slim or even Alpine, showing the distro of Linux, that are a kind of scaled back version. It's an easy way to optimize your image for size, but it might mean that you need to just make sure that the packages that you need are in there. You can always optimize this stuff later, and I'll go over a couple ways to do that in just a bit. Cool. One way I'll talk about is how we manage dependencies, and specifically we're going to talk about NPM and ways to optimize for package managers. This is a quick and kind of easy way where you can save some space and maybe optimize your image just a little bit. One other thing that Docker files are great for is leaving little breadcrumbs and hints, even documentation for the person who's going to use it after. So this has some notes about where we should expect this application to be running. I've left that hint, or the original author of this left that hint by saying, here's an environment variable with the port that you're going to need, or just simply by exposing it. That's a good signal if you're consuming this. Want to read through the Docker file and kind of look for hints about different ways that you'll have to configure your application based on the information that's in there. Finally, we have the command in here that's going to say, this is how we should start our application. We can also overwrite this at runtime. So this image has a lot in it. And a big image means it's slower to build. So if we want to optimize our dev cycles, we should optimize our images. One really cool feature of Docker is the idea of caching. So basically, Docker images are made up of all these little layers. And as long as the layers don't change, Docker is smart enough to say, I have that layer. I'm just going to use the cache. So if you write your Docker files in an efficient way or optimized way, you can really take advantage of caching and use it very effectively. So when the cache is a hit, we have that represented in green. And then as soon as there's one layer where the cache misses, it has to be rebuilt. So if you can order your layers in a smart way where the stuff that doesn't change is sort of in this bottom section, and stuff that does change often is more toward the top, you can make sure that you're really taking advantage of caching and getting the fastest build times as possible. So ordering layers for better cache usage is a rabbit hole that we could probably spend an entire 2-day conference talking about and debating about the right way to do it. One thing that I like to recommend to people kind of just starting out is that if you were using a package manager, so for example npm, or if you're doing like a bundle install, put that manifest file or the lock file or whatever manifest of your dependencies kind of, I guess, higher up in your Docker file or lower down on the layer stack, and run that dependency install separate from copying in all of the rest of your code. Your dependencies don't change that frequently. That way you'll save the time of a bundle install or an npm install every time you build the image, because it will be cached and you'll be able to use the cache. Then after that's run, you can copy in the rest of the application code. There is a talk today in this room at 5:25 about Dockerfile best practices with Tibor and Sebastian from Docker. I would highly recommend this. Is if you're new to Docker or even sort of an intermediate user, understanding Dockerfile best practices is probably one of the most important things and one of the best ways to spend your time here. So I would highly recommend checking this talk out for a little bit more detail about optimizing your images. Again, base images are also a way that you can optimize the size of your file or of your Docker image. So as I mentioned before, we're using Docker or Node 10.9 tagged with Alpine. There's also slim versions. On Docker Hub, you can take a look at the Docker files for these images and see all of the different versions. So this is just an example screenshot I grabbed from Node. But you'll see like there's a ton of different versions, and then even within each version, there's different sort of flavors. So make sure you're choosing wisely, do a little bit of research. One word of warning, if you're looking to pick a small image, the size that Docker Hub reports is the compressed size of the image, not the total amount of space it will take up on disk. So don't be fooled by a very small image and then wonder, oh man, why is this taking up so much space after you've actually pulled it from the Docker Hub? That's because it's showing compressed size on the Docker Hub. I've been bit by that before, so learn from my mistake. One last point about optimizing images, or maybe even trying to over-optimize them, is to avoid anti-patterns when you're going through this process. So simultaneous innovation is a term I like to describe for example, you're trying to optimize your images and then also learn how to use databases and containers at the same time. The more stuff you're trying to do and change, the more risk you're introducing and the more likely that you're going to run into some issues and maybe even have that project fail. So pick one thing, figure out how to do it, and then move on to the next one. Don't skip fundamentals like really understanding the Docker file. And then don't forget that Docker isn't magic. It's not going to do, it's not going to make it so that you don't have to worry about pinning dependencies or doing security scans. You still have to do all of those things, but Docker can definitely help it be easier for you. All right. Debugging in containers is the last section of this talk. As a developer, you probably spend like 75% of your time or more debugging and like the rest of the time writing code. So this can be a very important topic if you're thinking about running your dev environment completely in containers. The first thing, or sort of like debugging super simple, is just being able to access logs. And believe it or not, it's maybe really intuitive for some of you in this room, but if you're brand new to Docker, it might be really kind of a question of like, how do I actually get the logs out of my container so that I can read them and just look at the error codes and error messages that are happening. Docker Compose does this for you. There's a command called logs for Docker Compose. One thing is that when you run this command, Docker Compose logs, you're going to get all logs for all services. It can get pretty messy. Which I like to keep my dev environment sort of tidy. So what I prefer to do, and you saw me do this before when I started my application, is start Docker Compose up -d. So that will make it default so the logs will be suppressed. And then I can ask for Docker Compose logs and pass in the name of a service. I can also get timestamps by passing in -t flag. That's not there by default. So if you want timestamps, you have to definitely pass in the flag. I find that makes it so much easier for me if I'm debugging a specific problem that I'm not just getting a dump of logs for every single service in my application, but just a really focused set of logs only for the service that I'm trying to debug. And then timestamps are also super, super helpful there. At some points, you might want to start a container in what's described as interactive mode. So in general, like behavior for Docker ecosystem tools is that if you're trying to start up a container and it exits because something went wrong, you just kind of lose everything. You can't get in there and sort of debug, like, why is this command failing? Sometimes it can be hard to figure out why something isn't working. So you can definitely do this. You can start like an interactive shell and then kind of drop into your container via Docker Compose. You can list out the options to do that in Docker Compose in a YAML file. I know a few developers who prefer to do that. I don't really love this because I find that I'm usually doing these debugging exercises in sort of one-off things, and everything's sort of a snowflake at this point. I just prefer to use Docker itself for this. And the way to kind of get inside a container just with Docker is by passing in two flags, the I flag for interactive mode and the T flag for TTY. So Docker run IT, and then pass in whatever image. And then you can start with an entry point like bin bash. That will get you inside of your container with your environment, but it won't run that startup command. You'll just be able to say, if you're trying to run a test, for example, you do rspec, whatever, you'll be able to run that test and sort of act like you're just in an interactive shell. If you do need to mount your source code, you can also do that via the command line, just with Docker run. It's the -v flag. We'll do that volume mount like we talked about earlier with getting your local code inside of the container so that you can edit it and have those changes reflected immediately in the container. A couple other commands directly from Docker, which are really helpful during debugging, are Docker top. Docker top will give you a list of all the processes running in a container. So if you are ever curious, like what's going on in here, just use Docker top. And then my all-time favorite Docker command, maybe that's a big promise, but Docker inspect is so helpful. Docker inspect takes in sort of any resource. So let's say, for example, we're looking at an image or even a running container. You can say Docker inspect and then the name or ID of that resource. And that will give you literally everything you could ever possibly know about that particular resource. So whether it's a network, a volume, container, image, what have you, you can check out. So it has some interesting applications because you can use Go templates to format the output. So if there's something very specific you're looking for, you can use Docker inspect to get that information pretty much instantly. So one awesome example is figuring out what IP address a container has. You can use Docker inspect for that. And that's the example that I have down there on the bottom of the slide if you want to, I don't know, take a screenshot or check the slides later. But just passing in the container ID with this Docker inspect command will give you the IP address. That's really helpful as well to use in maybe a pipeline where you might want to inspect the IP address of a container. But there's all sorts of good stuff in Docker inspect. Great. So for my last trick, I want to show you how to do something that's a little bit less command line heavy and a little more just sort of you working in your development environment with your IDE. And this would be running a debugger. So for example, I'm going to use VS Code for this demo. But is it possible to run my application, my dev environment in Docker and then still use all the debugging tools, for example, in VS Code? And the answer, thankfully, is yes. So in this example, I've modified my Docker Compose YAML file just slightly. So I'm going to modify the command to start my example voting app to include that inspect flag. And I'm going to point it to a port that I have exposed inside of my Docker Compose file as well. On the bottom, I have 5858 exposed. That way, it just works sort of like it would when it's not running in Docker. Everything is there that my debugger needs. Cool, so let's go back to our application. And sorry, this theme might be actually a little bit hard to see. So I'm going to say Docker Compose PS, and I'm just using the terminal in VS Code instead of using the other terminal, just to show that it's possible. I'm going to take this down because I started this without the debugging command. So I'll take my Docker Compose file down and just wait for those containers to exit cleanly. Might just take a second. Oops. Great. So all of my stuff is now nuked from orbit, which is great. So I have nothing running. And what I'm going to do in my Docker Compose file, I'm just going to change the command and start in that sort of the debugging mode. Save the file, which is also helpful. And I'm going to start again with Docker Compose up/d because I don't want a super noisy terminal with a ton of logs. Cool. I can see success for all of the 5 services that are included in this app. And then I can go back to my application here. I have dogs voting for cats, and I can see things change. So I know that everything's up and running just fine. I'm going to start a debug session. And I have my launch JSON inside of VS Code. I'm actually not a Node developer at all, which is, again, I chose this demo specifically to show how easy Docker Compose makes things. But I have localhost 5858. That's exactly what I've exposed in my Docker file, or my Docker Compose file. So I can just attach it here. And then I can see that we're all good to go in the debug console. And I'm just going to set a simple breakpoint just to illustrate that this works. So we have here 1 vote, and it's a vote for cats. And that's exactly what I have here. I have 1 vote for cats, but I actually prefer dogs. So let's, instead of just 1 vote, let's say it's 500 votes. So I'm in a live debugging session. I'm going to change the variable value and then move over it. And I can see that that's actually updated right in my browser as well. So now down here on the bottom, I have 501 votes. That's taking the value from my remote debugging session using VS Code. So it's possible to have a total sort of end-to-end normal developer experience while still using Docker ecosystem tools and getting the benefits of sharing artifacts like a Docker file and Docker Compose files. Awesome. And that is actually it. I know we have some time left. I love to do Q&A sort of in smaller groups toward the front, so feel free to come up and ask any questions. Source code is available for this on GitHub. So yeah, feel free to clone it and just come up here if you have any questions.
You can also take questions from the audience now, or do you prefer the?
Yeah, I will not hold all of you hostage for a Q&A session. Okay. So feel free to hit the expo hall and get some coffee. And if you want to stick around for Q&A, feel free. But I won't be upset if you leave and get coffee.
Thank you.
All right, thank you.